All right. Okay. So today we will be discussing the 2022 September forenoon paper. So we basically have 6 more papers left. So 2022, 3 terms and 2 sessions in each term. So total of 6 papers. So we basically have 6 more sessions before end term. So we will be covering these 6 papers in these 6 sessions. So I've added 2 sessions per week. So instead of Tuesday and Friday, we also have Wednesday and Thursday. So let's start with the paper today. So the first question, hopefully the screen is visible. Let me know if I need to zoom in more than this. So the first question, here we have the help of the echo command. So the how the echo command works is given to us. So what minus n does, what minus e does, etc. is mentioned. And we also know that \n basically means a new line. So we can type \n in echo to get a new line if we have the minus e flag. So if minus e is on, then \n will work. So for example, if I do echo a \nb, this will simply print a \nb. But if I have minus e, then it will treat this as a escape character, which is a new line. So it will be a, then new line, then b. And so now the question is, given this 3 echo commands, what will be the output from this? So here we have the minus n in all of these. So minus n basically means do not append a new line. So by default, if I print anything, so the text is printed and my cursor goes into the new line, so that our prompt can be there. Or if we have, let's say, multiple echoes also, so what will happen is after the first one, the cursor goes into the next line. So the next one is printed on the next line. But if you want the cursor to not go into the next line, then we can simply use the minus n. So this will suppress the default printing of the new line. So then we will have the first thing printed and then the cursor will remain and then the next thing is printed directly beside it. So we have minus n on all of the echoes. So we are never going into the new line automatically unless we have manually specified in the \n. So in here, we have the first command, which is echo minus n star and then a space in quotation. So this will simply print a star and a space on the screen. And our cursor will not go to the next line because we have minus n. Then we have echo minus ne. So minus n again will not go into the next line automatically at the end. And e because we are using \n inside. So after the star and the space, we are then printing another star. So we will basically have something like this. So we'll have a star first, which is due to the first command. And then we'll have a space. And then after that, we'll have another star. So we'll have 2 stars side by side with a space. Then we are printing the \n and we have minus e. So the \n actually gets converted into the new line. So then we come into the next line here. And then we are again printing a star. So we print a star below the first star. Then we again print the \n, which is a new line. So we again go below into the next line. And again, we print a star and a space. So we print a star and a space. So our cursor is now here. And in the third command, we again print a star and a space. And here also, we don't have the new line automatically printed. So we print a star here and a space. So this is what is printed. And then this is obviously the
new line, right?
No, it will not go into the new line. So basically after this, whatever prompt you have, right? So that prompt will be present here after the star. But the output of this will just be this part. Right, so now out of the options, we have to select which one is correct. So here we are getting star and then 3 star and then 1 star, which is not correct. Here we're getting 5 stars consecutively, which is also not true. So we have \n, which goes into the new line. So here it's telling that the \n will be printed as it is, which would have been true if the E flag was not there. But because we have the E flag, that's why they will be in a new line like this. So the fourth option is correct, where we have this C-shaped star pattern. So hopefully this one is clear how we're getting this pattern.
Yes.
All right. Okay, so let's move on to the next one. So in this question, we basically have a theoretical question. So a college student uses a pen drive to store files. The pen drive is always mounted on his system at /mount as a separate file system. His pen drive contains lots of files and directories, and he wants to create a link to the directory /mount/bio/phase-2/project-312 inside his home directory. So what link can the student use? So what are the two types of links that we have?
Hard links, soft links.
Yeah, right. So is both of them like theoretically possible to be used in this case? Can we use soft link to do this, and can we use hard link to do this? So which one is better comes later, but can we even use both of them in this case? Or is there any
We
restriction?
can't use hard link because we won't be able to duplicate the mounted device, right? I mean, I think that.
Okay, so you're close. So what constraint do we have on hard links? So there are two constraints on hard links, which is not there on soft links. So one constraint is you cannot have it on folders. So that is obviously violated here because we are want to create a hard link to a directory. And another constraint is also there, which is also violated. So what is that in hard link? When can you not create a hard link of a file? Any idea? Okay, so
I think directory. I think directory are one we cannot create a hard link, right? I remember
yeah,
reading it sometime.
Yes,
yeah, yeah.
directly. Yeah.
Yeah, you cannot create a hard link of a directory, and
Yes.
also you cannot create hard links across file systems. So note here, this is on a pen drive, whereas he wants to create the link on his /home somewhere, right, in his home directory. So the home directory is obviously on his hard disk or his solid state drive disk, basically any disk which is installed in his system, whereas the file is in his pen drive, which is a different file system. So you anyway cannot create a hard link even to files across different file systems. So hard link to files or directories on different file system is not allowed. And obviously hard link on any file system of directory is also not allowed. So due to both these cases, hard link is not possible at all. So although soft link does not have such restrictions, so he can use soft links. And what is another difference between hard link and soft link, due to which he can create this link, and when let's say the pen drive is not mounted, like it will not cause any issues, it will simply not work. And when the pen drive is mounted, then it will automatically start working. So it's because like the soft link uses the path, right? So whereas hard link actually needs to store the like the actual inode number, yeah, and the actually where it is pointing. But the soft link will simply point to a path. So if that path does not exist, the link will be broken. And as soon as he plugs in his USB and mounts the USB, the path will again exist, and the link will also again work.
So there are two types of paths, right? So
Yeah,
relative path and absolute path.
yeah. So in this case, we
Both
are
we can use.
you can use both because you're not moving the link. If you move the link from one place to another, it may cause an issue. But yeah, you can use both. So in this case, usually you will just use the absolute path, right? Because anyway, it is like the path of it is /mount. So slash is the starting part of the directory. So this is an absolute path. So if you want to have a relative path, you basically, if you're in your home directory, you have to do ../../ this entire thing. So this entire thing anyway you have to write, and you have to write two dot dots before. So the relative part does not really make much sense. You will just use absolute path, but both will work in this case.
Okay.
Yeah. Right, so this is why we will be using soft link in this case. Hard link will not work, and obviously either will work is also incorrect, and link will not work for this requirement is also incorrect. So soft link will work for this.
Hard link will not work because it's a separate directory. It's a
Hard,
separate hard border, separate file system.
yeah, separate file system, and also because it is a directory, so we cannot create hard links on directories, even
Yeah,
if it is on
correct.
same file
Yeah.
system. Yeah, so both the reasons. All right, so let's move on to the next one. So here the question is, so given this sequence on VI or in Emacs, what will the final output be? So I'll do it on the VI. So both of them has the same answer. So let me just copy this. So in here, we are told that we have to do these following on a text file. So if we have, let's say, a text file which has a lot of lines, so the first command we are using is capital G. So what does capital G mean in VI? Anyone?
Global.
No, so in VI, when we are in the escape mode, so capital G will mean go to the last line, right? So here, wherever we are, so usually the cursor will remain wherever you were the last time. So let's say the cursor is maybe here. So when I press capital G on my keyboard, cursor will move into the last line. So now
first
basically,
line?
sorry?
To move the cursor to the first line?
Then we use this GG, lowercase g,
G.
lowercase g. Yeah.
V means visual mode, right?
Yes, V means to enter into the visual mode. So when we have pressed capital G, our cursor wherever it was in a line moves same place in the last line. But now it is in an arbitrary place in that last line. So we press dollar. So dollar means go to the last character of the current line. So now our cursor goes into the last character of the last line. So now we are at the end of the file, and then we are pressing V. So lowercase v means normal visual mode. So this is a character by character visual mode. So now we are in visual mode, which means it's like selecting something. So whenever basically I type something and then I select it, right? So if I type something and then I'm selecting it like this using the mouse, so that is visual. So in VI also you can select things using the visual mode. So at the last character of the file, I am now in the visual mode. So now we type GG. So GG means go to the first line. So now the cursor moves into the first line. And because now the visual mode is started, the entire thing is selected. So from the last character till the last character of the first line is selected. So now this is selected. Now we press 0. So what does 0 do? This is opposite of dollar, right? So what does
So
0 do?
starting of the line.
Starting.
Yeah, so it'll go to the starting of the line. So now the cursor, instead of being at the end of the first line, it goes into the start of the first line. So we are still in visual mode. So now the entire document is selected
Select.
from the last character till the first character. So then we use the Y. So Y is copy, or Y basically stands for yanking. So the entire selection, which is the entire document, is yanked into a buffer, which is the default buffer. So which means it is copied. So now the entire thing is copied. So the text remains as it is, but everything becomes copied, and we automatically come out of the visual mode because we have performed a operation. So as soon as we perform an operation, we come out of visual mode. So now we then press G to again go into the last line, and then we press P to paste whatever we had copied. So because we had copied line by line, so the entire line will be pasted below this. So again, the same thing. So basically, if we had line 1, 2, 3, 4, again we will get line 1, 2, 3, 4 below. So what this will do is it will copy the entire document and paste it again below it. So let us also try to do it. So let me create a folder, a file, and let me just add a few lines here. Okay, so now let me turn on screen key so that you can see what I'm typing. So the first thing, let's say my cursor is, so let's say this is what we have. So let's say my cursor is somewhere in here. So then the first thing we do is we press G to go into the last line, and now my cursor is somewhere in between. Then we press dollar to go into the last character of the last line. Then we press V to go into the visual mode. So now we are in the visual mode. So now if I press GG, lowercase gg, so now we go into the first line's last character. So now as you can see, everything is selected till that. And then if I press 0, so now we are in the first character and everything is selected. So now if I press Y, so now everything is yanked into the buffer. So, and the visual mode is now disabled. So now if we press capital G to come to the last line, and if we press P to print, so print it, so you can see that it has copied the same thing and pasted it again. So although like I think one letter has been misplaced, so ideally what you should do is you should again go into the last line, last character by pressing dollar, and then you should print so that it comes after this, or even better, you should first press O to go into a new line, and there you should paste it with P. But either way, we basically copied the entire document and pasted it again. So the placing is at the last line. So now we have the same document present 2 times, or a copy of the entire document is done in the same file. So that is the option in this. So we have 4 options: cut the paragraph and paste at the end. So obviously we are not doing cut. So to do cut, we had to use the D character, but here we are using the Y character to copy. So next is copy the paragraph and paste at the end of the document. And what is the okay, so we are not copying the paragraph, but we are copying the entire file, right? So because capital G and lowercase g means go to the last and first lines. So it does not depend how many paragraphs there are. So then the third and fourth are same thing, but instead of paragraphs, it is the entire document. So we are obviously not using cut. So we are doing copy paste the entire document. So in the end, we will have 2 copies of the initial document. So that's how we solve this. So similarly, if you are familiar with Emacs, you can also solve it using the Emacs shortcut as well. So hopefully this is clear. So let's move into the next one. So in this next question, we are given a script here. So we have to select the correct statement based on the below script. Assume that file 1 is not empty. And we are also given a hint that T command takes the standard input that it receives and prints it to the terminal, and also writes it to the file that is given as argument. So for example, here right now I have just one file. So if I, let's say echo hello, new line, world, I also need the E. Stop this. Yeah, so if I simply print this to the standard out, we get this. But if I redirect this to the T command, so what T will do is it will print it to the standard out and also store it into a file. So for example, if I give it a file called output.txt, so we still get the output and the screen, but it is also now stored in a file called output. So that will also store what we send to it, and the screen will also get. So that is how the T command works. So in here, what we are doing is while read line do done. So this is basically a loop that reads line by line from the standard input. And instead of the standard input, we have given file 1. So file 1's contents is given as standard input to this. So this is same as cat file 1 pipe this while loop. So basically this while loop will read each line one by one from the file 1. And inside the loop, we are simply just again printing that line. So again, we are just printing the same line. So then we are redirecting that output of the while loop into the file 2 file. So what happens when we redirect a output to a file? So the standard output will not receive anything, right? So for example, if I do this one, echo hello world, so if I simply run it, this will print it to the screen. And if I, let's say, redirect it to output2.txt, so sorry. Yeah, so if I redirect it to output2.txt, so you can see that this file is created, which has the what I asked it to redirect. But when I run this, the standard output will not have anything, right? So nothing is printed to the standard output. And here what we are doing is we are then piping that to T. So T will not get any standard input because the while loop will not give any standard output, because whatever was coming is already redirected to file 2. So thus this T will not get anything. So T will neither print anything to the screen and nor it will store anything into the file 3, but it will create an empty file, file 3. So at the end of running this, whatever was present in file 1 gets copied in the file 2, and empty file 3 is created. So nothing is stored in that file 3. And also on the screen, nothing is shown. Right? So let us now see the options. So the first option is file 2 will be empty, which is incorrect because file 2 will contain all the lines of file 1. The second option is file 3 will be empty, which is correct because T is not getting any standard in, thus it will not write anything into file 3. The third option is content of file 1 will be displayed in the terminal, which is also not true because T does not get any standard in, so it cannot also print anything to the screen as well. And finally, file 3 will contain contents of file 1, which is also not true because, as we saw, file 3 will be empty.
But sir, in the pipe command, the input, it generally passes the input from the previous command to the following command. So in this case, because it is not echo file 2. Okay. So
No,
that's why.
because yeah, we have already redirected its standard output to a file, right? File 2. So
Yeah,
now
so
no
there is
longer
no standard
standard out of this.
standard out of this. Okay, okay, that's why.
Shayan, if file 2 wasn't there,
Yeah.
let's say, then what would happen?
So then we will get the contents of file 1 on the screen as well as stored in the file 3. Because then whatever the while loop was printing, that entire thing would be redirected to T, and T would print it to the screen and also store it in the file 3. So let us also like run this and see. So here right now I don't have anything. Let me write something. So let me simply write this into a file called file1. So right now I have only one file called file1, which has hello and world in it. So now if I do this, while read line, do echo line, done, and I get it from the file1. Right. So if I simply run this, then obviously it will just print it to the screen. No other files are created. Nothing is changed in file1. Now, if I, in this case, if I now redirect this to file 2 and then type it to T file 3, then when I'm redirecting it, so let me just first do this. So if I'm just redirecting whatever was printed, so here hello world, so I'm redirecting everything into file 2. So now nothing will be printed to the screen. So there is no standard out of this command. But now we have a file called file 2, which has the same thing stored in it. So if we then run the same command and pipe this into T file 3, so as we saw, this does not create any standard out. So if nothing is created as standard out, T gets no standard in. So a file 3 will be created, but it will be empty, and also nothing will be printed to the screen. So now you can see file 2, as we saw earlier, contains the same as file 1, whereas file 3 is an empty file. But instead of doing this, if we had not done this, right, so if we simply run this, then we saw it will print the contents of file 1 to the screen. And if I pipe it to T file 3, then we are telling this standard out of this command, take it as standard in to T. So T will then print it to the screen and also store it in file 3. So now we will get the contents of file 1 on the screen, and also file 3 will contain the contents of file 1. So if there was no redirection like this, then we would get basically option 4 as correct and option 3 as correct. And if there is obviously no file 2, then option 1 is also correct. But because we have this, then A, C, and D are incorrect, and only B is correct.
Is there any way we can, I mean, I know that original, I guess the intention was to make 2 copies of file 1, one through redirection, other through T. Obviously, is there any way we can do to make that happen, like
Yeah.
1 greater, 2 greater than?
Yeah, so not with redirection, but with T itself we can do. So for example, if I remove this file to file 3, right? So again, we are back to just having file 1. So if I do this, so first of all, we don't need like a while loop. We can directly use cat, but let's say we are doing this. So if I first pipe this to T and give it file 2, and then if I redirect its output to file 3, so now what is happening? This will print just the contents of file 1, right? So this is same as cat file 1. So I'm catting file 1, then I'm piping that to T file 2. So what T file 2 will do, it will, so what T will do, it will store whatever I'm giving as standard input into the file 2. So first part is done. I've successfully copied file 1 into file 2, and it will also print it to the standard out, right? So now it will also print to the screen the contents of file 1, but that I am redirecting into file 3, right? So in the end, nothing will be printed to the screen, and contents of file 1 will be stored in file 2 and file 3. So if I run this now, what happened? Why is this not running? Okay, yeah, I forgot to give the standard in itself. Yeah, so yeah, I have to give it file 1. So if I'm running this while loop on the file 1, and then I store it using T on file 2 and file 3, so then you can see we now have 3 files, file 2 and file 3. So file 1 will remain as it is. So let me just print all of them. So you can see file 1 is as it is, file 2 is a copy of file 1, and file 3 also is a copy of file 1. So you can do this, so if I again remove them, file 2 and file 3. So you can do this even simply by simply doing cat file 1 T file 2
and file 3, yeah. Just without greater than, will it work?
Maybe I think, let me see if yeah, T takes multiple files also. Yeah, you're right. So we can, without this also, we can directly do T files. Yeah, so this should also, so this is also printed to the screen. So depending on your use case, this might or might not be what you want, but this will basically create the 2 files as well, and it will also print it to the screen. Yeah. So hopefully this one is clear why this is working this way.
And if you want to suppress the output, you can do 2 greater than dev null.
Yeah, but then it becomes like too much typing. Instead of that, we can directly do this also. This would have been better.
Correct. I'm just saying, if it's MSQ, going with the pattern, how we have.
Yeah, that also will work, obviously. Yeah,
This
we can do
problem
it.
came in quiz 2 actually.
Yeah, this term itself, right?
Yeah, this term it was there. Quiz 2.
Yeah. So hopefully this is clear. So let's move on. So next question, choose the regex to match with a string that contains at least a character repeated 3 times. Assume that the regex is ERE. So this asks us to write a regex that will match any string that contains at least a character repeated 3 times. So there can be more than one character repeated 3 times, or there can be a character repeated more than 3 times also. But at least
Is
if
it
it is
consecutively or just 3 times?
Yeah, so in this paper, in the forenoon paper, it is not mentioned consecutively. In the afternoon, it is mentioned consecutively. So here it can be basically present anywhere. So just a letter being present 3 or more times in a string may be consecutive or may not be consecutive. Right, so how can we do that? So let me actually write a file so that we can see. Let me be in T1. Okay, so let's say I have a data.txt, and here I have a word hello, and then hello, how are you? I don't think anything is still repeated till now. So here we have the letter L repeated, right? So L is repeated 2 times here consecutively, and the 3rd time here basically non-consecutively. So here this should basically print the 3rd line, and hopefully no other character is present 3 times in the other lines. So yeah, let us see what regex can do that. So obviously we will be using grep, but then what regex do we use to match this?
So minus E.
OE is repeated, right? OE is repeated 3 times.
No, in each line. Okay, yeah. O is also repeated.
OE is also repeated.
Yes, so O will be printed in this. I mean, and so both these lines will be printed. Or let me just remove this. Okay, so now only this line should be printed. Yeah, so with eregex, how do we match this?
Bracket dot.
So take
Dot
any
slash.
character, bracket dot.
Yes.
Bracket.
Uh,
Curly bracket 3.
/3.
Okay, slash as in backslash or forward slash? Like this one or this one?
So just curly bracket 3.
This
Curly
should be
bracket. Okay,
no,
so
this means it has to be consecutively.
2 things.
Yeah.
So this means it has to be consecutive, and also this means it can be any character. This does not mean that it has to be the same character. So this will actually match all of them, right? So you can see HEL is also matched, and then obviously like all of these are also matched.
Oh, sorry, backslash
Same
1.
character is
Yeah. So if you want to have the same character, how do we do it?
Backslash 1.
Backslash 1, right? So not
Yes.
backslash 3, because there is only one group. So it is backslash 1. So this means the same character present again consecutively. So what do we want to do? What should
Curly
be
bracket. Backslash 1, curly bracket 3.
again /.
Okay, so this will only
One.
match if there is 3 same letter consecutively. So in this we don't have, but let's say I add that also. So in that case, it will only print that line. It will only print this line and not this line. Whereas our question asks any like present 3 times anywhere, not just consecutively.
So
how
then between the bracket close and backslash 1, we can put a dot star.
Yes, exactly. So we can tell any character any number of times, but also 0. So it may be consecutive or it may not be. So if we do it in both the places, then this will basically print this and this. So this LL and all of this is the dot star, and then again this L. So this is one match, and then this is one match. So this is how we solve this question. So we group this character, obviously, because we need to back reference it if we want the same character. And also between them, we have to put dot star because we want with or without consecutiveness. So that is basically, there are these options.
And
So
what does /1 here indicate? /1?
/1 means the same character which was matched in the first group. So here we have this group, right? Round brackets.
Okay.
So yeah,
It's
so this is
referencing that group.
Yes.
So you are referring that group twice, right?
Yes. So here and here.
Okay.
Yeah. And between them, there can be any character any number of times.
So instead of dot star, if you put star, what does that mean, Chan? I mean,
no. So in regex, star in itself does not mean anything. It is a qualifier. So if we just do this, so this will basically not match, right? So I think this will simply mean that this group can be present 0 or more times. Similarly, this back reference.
Got it. Yeah, it's basically referring to the previous preceding character.
Yeah.
Or group, whatever.
Yeah, exactly.
Regex is endless possibilities. You could do like 100 PhDs.
Yeah. And there are also like multiple variants also. So BRE, ERE, PCRE. And even in them, there are multiple.
Thank God is ERE. I think we should learn how to do this in BRE. By removing minus E, all you do is do all the backslash for star.
Okay, so which characters need to be escaped in BRE?
The open bracket.
Dot.
Do I need to escape the dot?
No,
right?
Star definitely.
No. Star is also there in both BRE.
Curly braces.
Yeah, so we don't have that. So right now we don't have to. So here we don't need to escape anything else. So that's will.
Then what are the characters which have to be escaped in both ERE? And I was trying to make a note of it last time.
Yeah, so basically anything that has a special meaning, right? So if you want to match it literally, so
correct. No, I'm wondering which are the ones which are common to both ERE and BRE.
Yeah, so basically if you go into BRE syntax, so anything that is there in BRE, it is also there in ERE. So star, dot, caret, dollar, then this square brackets, opening and closing square brackets. These are the things that you have to escape if you want them literally. So the plus obviously in BRE you don't need to escape, but in ERE you need to escape if you want it literally. So these are something we have already seen.
Common,
so plus,
common to both. Yeah. Okay.
Yeah. But these things which are basically common to both, you have to escape them if you want them literally. Right. So
Chan, sorry, because you said this escaping, I just remembered one thing. You can show it later. I know it's like we won't have any OPE now, but when you have to see when you're writing as command line, when you write a set script in command line, you can reference ERE because you can say capital E. But when you write set script, how do you do it inside the script? You can't, right?
So it depends. If you're running the set script this way, right, /script.sed, then if you have in the shebang, so in the shebang, let me just abuse the notation and write it here itself. So if I do it this way, then this will work. So it will use the ERE.
Okay.
But it will not work if the evaluator is running it this way. So then it will not work. Because then it will just read this as a comment and ignore this.
Okay.
So if it is run with
you can't give FE here, right, in the command line.
You can like you can do EF, not FE, because F takes the argument.
F has to have the file after that. Correct.
Yeah, so you can, but obviously in OPP, if let's say this is part of the eval script, you cannot change the eval script. So in that case, you cannot. But theoretically, obviously you can. So you can add the -E here, or you can add it.
Eval script actually does sed -F. I've seen that.
Yeah. So in that case, you have to use BRE itself, right? So you cannot use the shebang also.
I think you told that sed is by default BRE and awk is ERE.
Yeah, exactly. Yeah. Right, so in this question, then we have the first option, which is simply 3 dots, right? So this can match any 3 consecutive characters. So this is not correct. And then we have dot star, which basically means minimum 3 characters, but maximum, minimum 0 and maximum any character. So this dot star is same as just 1 dot star. So this will match anything and everything. So this is again not correct. So this is correct for consecutive 3 same characters. So we are matching 1 character, then referencing that 2 times. And this, which we did now, is matching 1 character, then anything between, then the same character, then again anything between and the same character. So this is consecutive or non-consecutive. And the last one basically says that this has to be the entire thing in these lines. So basically the line has to start with that character and end with that character. So which is obviously not something that will always be true. So that is why this is also not correct. So option D is correct.
So dot
Yeah,
star.
option 3 should be correct, right?
Sorry?
Option 3, why option 3?
No, in option 3, this will only match for
Consecutive.
consecutive. Yeah. Whereas our question asks, does not specify it has to be only consecutive.
But it is not wrong either, right? Given
No.
the question.
Yeah, so the question is choose the regex to match string that contains at least a character repeated 3 times. Yeah, so this will match a subset of what we
Actually,
want.
that way, if you that's right. Actually, because even then the 5th one is also a subset of 4.
Yeah, so if this was, let's say, MSQ, then I think these also would have been correct. But because this is MCQ, obviously we'll select the one.
Okay, MCQ. Okay, only one is correct. Sorry, sorry about that. Yeah. Okay, I always assume MSQ. Okay.
Chan, one question.
Then we'll pick the best one. Yeah. Then both of them.
Chan, that dot star.
Yeah.
If I just said dot, that also technically will match anything, right?
No, that will match anything but only once. So we are telling
only one character of the entire line. But, okay.
Yeah, so if I basically say dot and then \1, so this means the character has to be basically the duplicate character has to have one character in between them. So it may be not one, it may be multiple, it may be 0 also, right? So it may be consecutive, it may be multiple characters. So like in this case, we saw there's so many characters are there between this L and this L. So if we give dot, it means just it can only be one character. So it has to be like HEL, then some character, then L, then some character, then L. It cannot be 0, it cannot be more than 1. But we should allow any number of characters, even 0. So that's why we have dot star.
Actually, when we read this question, it feels little ambiguous because it is left to our assumption whether it is asked on, because it says at least a character repeated 3 times. It does not say whether there are possibility of having other characters in between. I mean, that's my personal.
No, actually, the thing is, right, the only thing which we can assume is if any character has to appear thrice, doesn't matter whether it is. So the language is clear. One confusion we can possibly get is whether continuous or not. Other than that,
that's only confusion, whether they are expecting continuous repeated 3 times or they would be
so like usually if like it's not mentioned, we will consider the more generic case. So it's just told 3 characters repeated 3 times. So like if we think that repeated 3 times means consecutive, then it can be confusing. Yes, I agree with you on that. So like if you see both the papers, then it is clear, because in one of the paper it asks repeated 3 times consecutively, and in this one it does not ask.
I mean,
but if you just see one paper, then it will be confusing.
I mean, I would go by when it says repeated 3 times, I would feel consecutive is closer to the statement.
Touche. Makes sense. But in this, basically they are asking either consecutive or non-consecutive. So if that is the question, then this would be the answer, and if it is consecutive, then this would be the answer.
But it's MSQ?
And if it is MSQ, then C, D, E all should be like technically correct.
Just checking.
All right, so let's move on. Right, so in this one we have the N, which appends the next line into the pattern space. So we're told what does the set script do? A hint is that capital N commands in set appends the next line to the pattern space with the new line character \n being the separator. So let me directly do on this file itself. So if I simply do sed substitute \n with nothing on this file, so you can see there is no. So there is that is what I'm showing, that it will actually not do anything. So that is because when sed reads each line into the pattern space one by one, it will only read the contents of the line and not the \n. So it will not read the \n. So in each pattern space, you only have the contents of the line. So and even if you had the \n, you are removing the \n, but sed will anyway process line by line. So it will process one line, do the substitution that you're asking, print that line, then it will go into the next line and print the next line. So here, because the \n is not there in the pattern space, this substitution will actually not do anything. So in order to get the \n into the pattern space, so what we do is we use the capital N. So when we use the capital N command, what this will do is it will, by default, it is loading the first line in the pattern space. But when we do capital N, it will also load the next line into the pattern space. So now we will have the first line, then a explicit \n like escaped character, and then we will have the next line. So we won't have \n after this next line. We will only have one \n between the first and the second line. So then after loading two consecutive lines in the pattern space, if I substitute \n with nothing, basically if I remove that \n, so let me also remove the G because there is only one \n. So if I remove that, then we will basically get the two lines side by side. So they will come side by side. And because we use the capital N, so because the second line was loaded in the pattern space in the first cycle itself, so in the next cycle, it will directly start from line 3. So this is loaded automatically, and then the N loads the next line as well into the pattern space. So again, on this, the same thing happens. So every two line gets concatenated this way, side by side. And so similarly, if I use two N's, so then what will be the output of this?
One first, second, third will get.
3 lines concatenated.
3 lines.
Are you sure about that? Okay, so let's do line by line.
One second.
Yeah.
I think it will print everything in the one line.
So all the 4 lines.
Yeah.
3 lines concatenated.
Okay.
The first 3 lines will be one line, and the fourth line will be the second line.
Yes.
Okay, so we have two basically wages. So let us see then like one by one.
2, 3, and 4.
Sorry, I didn't get it.
1, 2, 3, and then fourth line.
Okay, so 1, 2, 3 in the same line, and then the fourth line, right?
Yeah.
Yeah. Okay. So let's see one by one. So the first N will, when we have already loaded the first line, so the first N will then load the second line also in the.
Okay. All the lines it will concatenate.
Okay. So spoiler alert: both the options that you have presented are actually not correct. So let's see why. Right. So the first N loads the second line in the buffer, right, and then the next N loads the third line.
Only
so
there
now,
are 2 lines, right?
we have total of 4 lines. Yeah. So but in the first time when we have N, yeah. So it's loading the first 3 lines in the pattern space. So we have line 1, then \n, line 2, \n, line 3. Right. So then what are we doing here? We are substituting \n with nothing.
So,
right.
One more thing, we forgot the G. Now I understand.
Yes. I removed it intentionally. Right? So that is what I was asking. So if you don't have the G, it will only remove this first \n. Right. So the first and the second line will be concatenated. The third line will remain as it is. Right. So if I run this now, you can see that the first and second line are concatenated. Third line is as it is. And if we had more lines, then fourth and fifth would have been again concatenated. Sixth would have been as it is. So let's say this is fifth line. This is sixth line. Right. So if I run this again, so you can see first and second are concatenated. Third is remaining as it is. And then fourth and fifth are concatenated. Sixth is remaining as it is. So you had this in the, I think, quiz 2 or quiz 1.
Quiz 2, we had it actually. And then to make things interesting, you can put pipe it to WC minus L.
Yeah, you can also.
If you do G, what happens?
Yeah, so then it will concatenate all the 3 lines side by side. Right? Because we are substituting all the \n in the pattern space. So we'll have first line, second line, third line. Then we'll have fourth line, fifth line, sixth line, side by side. Right, so if you have G, then all the \n in the pattern space will be substituted. If you don't have, then only one will be. So in this case, in this question, we have the G. Right, so what we're doing is basically the same thing. So we're doing capital N, and then substitute new line with nothing G. So we are simply putting 3 consecutive lines side by side. Then again, the next 3 consecutive lines side by side. Right, so that is the question. So here, I think we can see the options. So merge every 2 consecutive lines. So that is not correct. Merge every 3 consecutive lines. So this is the correct option. Obviously, we have the another option, merge every 4 consecutive lines. So this is not true. And input remains unaltered is also not true.
Can you talk about that CRLF? \n is fine. There is also CR and LF.
Yeah. So yeah, if your file has CRLF, then like the CR will remain as it is. The LF will be removed. So if you are on Windows, let's say, so if you just have CR, then it will not treat it as line break. So even if we remove just the LF part of CRLF, it will still like basically be side by side. But one issue can be there that basically if you know what CR is, basically it means that the carriage returns to the start of the line, right? So if I print this first part, and then if it actually prints the CR, then the cursor will go to the start again. So when it is printing the second line, it will actually override the first line, depending upon like which one is longer, the first line or the second.
There can be a question on what will be the output. So that means, and if my length of my first line is smaller than the second line, I will not see in the first line. I will only see the second line.
Yes, exactly.
That can be a quiz question, right?
Yeah, and then the third line also, right? Because we have two ends, so third line length also. If it is then greater than both, then you will only see third line. If let's say second line is greater than both, then you will see some parts of the second line, and rest part will be the third line or something like that. Right, so that will be a very tricky questions. I don't think that will be asked.
Sorry, sir. I mean, our minds have been twisted now. I was never
yeah.
But after quiz 1, quiz 2, we are just not going with the straight answer. Like, okay, let's see how many possible ways, can this be asked.
Yeah, exactly.
Just get ready mentally. That's all. The outcome will still be the same.
Yeah.
So can you please explain this NN without the G once again? I'm a bit confused. The first N that we do will concatenate the first two lines.
No, N is not concatenating anything. So it will just load it.
It basically allows us to take the \n.
Yeah. So first, in the first cycle, only the first line is there. Then because we have this first N, so it then loads the next line into the same pattern space, right, in the same cycle. So then we have another N, so it loads the third line also in the same pattern space. So now my pattern space is hello \n, hello hover \n, hello, this is a file, and then the end of the pattern space. Right, so we have two \n's between the first and second line and between the second and third line.
And it will only substitute the first one.
Yes,
so the third line will come. Okay, got it.
Yeah. So then what will happen is first and second, because the first \n is substituted with nothing. So they are side by side. And the third line, it is as it is. So now because we had actually read that line also in the pattern space with the capital N. So in the next cycle, it will directly start from this line, right? Fourth line. So again, in the fourth line, it reads these three total lines. And again, it will only substitute the \n after this. So this will again become hello, this is like fifth line. And again, sixth line will remain as it is.
Okay, good.
Right?
Yeah,
so,
thank you.
Yeah, sure. So if you have G, then it will just concatenate all of them together. Right, so hopefully this one is clear. So let's move on to the next one. So in this question, we are given the awk script and we are told what will be the output from the below command represent. So given that this awk script run on some file, so what are we running? For every line, we are basically using a dictionary or associative array, and we are storing the entire line as the key, and the value is simply whatever was the value plus 1. So in awk, by default, a variable's value by default is 0. So whenever this is run, it will keep on incrementing from 0. So it will become 1, 2, 3, etc. So this is just storing the count of each line in the file. Right? So we have also seen this multiple times earlier. So we can use this to count the lines in a file. So then we're not doing this in the end. We are doing it in the same place here. So what we're doing is after this block, we are telling if ARR, the $0, so same thing, is if it's equal to 2, then I am printing. So just typing print will print the entire line or print $0. So I'm printing the entire line if ARR $0 is equal to 2. So what will be the output of this?
Any line which has come twice.
So any line
which is at least 2 times.
Yes, and why is that?
Because it's not yet recorded if it will come 3 times.
Yes, exactly. So when it is the first time, the value of this will be 1 and this will be false, so nothing is printed. When it comes the second time, this will then increment into 2, and here then this will be true, so it will be printed. But then it might be again that later somewhere again that line is there, and then this value becomes 3. So when it is 3, obviously it will not print it again, but in the previous time when it was 2, it was printed. So it will print not just lines present 2 times, but also lines that are present 2 or more times. So 3 times, 4 times, etc. And so hopefully this is clear why it will print lines that are present more than 2 times also. So options, the first option is lines that are distinct, which is obviously not correct. We are seeing that the count is equal to 2. So the next question is the lines that are repeated exactly twice. So this might be our first guess, but then this is incorrect.
That would happen if you put it in the end block, right?
Yes, yes. In the end, after processing all the lines, if you then check that, so in the end also you cannot actually check. So you basically have to iterate over all the keys, right? So you have to do for k in ARR. Then you have to say if ARR k equals to, then you print
correct.
k. Yeah. So yeah, that you can do. So then it will only print those lines that are present exactly 2 times. But because we are doing it for each line, thus it will print lines that are repeated twice or more. And this one is obviously not correct. So it is not lines that are present only more than twice. It can be 2 or more than.
How can it be more than twice?
So when if a line is present 3 times, so what will be the value of this ARR $0? So it will start with 0, right?
Okay, it will become 3, right?
No, when the first line is encountered, what will be the value?
First line is encountered, it will be 0 and it will increment to 1.
Yes. Then again, when that line is again encountered, what will be the value?
When the line is again encountered 1, it will become 2.
Okay, but it was present again later, but now the value is 2, right?
Now, so when the third time comes, when it encounters the third time, won't it get incremented first?
Yeah, it will become incremented, but for each line, I'm also...
It's already printed, right?
Yeah, so for each line, I'm also doing it, right? I'm not doing it at the end. I'm doing for each line. First, I'm incrementing, and then I'm checking if it's 2 and printing. So even if like sometime
so when you see the third time or when you encounter the line the fourth time, what will happen is that would have already been 3, right?
Yeah. So see, when it is first time, when it is 0, and then when we encounter the line first time, it becomes 1, right? So when it is 1, it is not equal to 2, so it is not printed. Then when the line is encountered again, it becomes 2. So when it is 2, then this condition is satisfied, right? So it will be printed. So the line gets printed. Now, if the line is again present another time, then again it will increase to 3. So when it increases to 3, it will not be printed again. And similarly, if it again increases, it will not be printed again. But it was already printed when it was 2, right? So if a line is present 2 times or more than 2 times, the value of that counter will at some point of time will be equal to 2, right?
2, okay.
Some line. So at that time, it will be printed. That line will be printed.
Okay. When it is 2, it will get printed, but more than 2, it will not get printed. But that line is already printed, so we have to. Okay.
Yes. So any line that is present 2 or more times will be printed exactly once by the awk command.
So now we're thinking what changes we can make to the existing code. So one of the options is right. So if I make the change error $0 equal to 1, then the option 1 will be correct.
No. So again, same thing, right? So then any line, all the lines will be printed because all the lines will have the value 1 at some point, right? Whenever it is 1,
so less than equal to 1, less than equal to 1. No, still
no lines will be printed.
No, that if you're looking at lines which are only printed once.
Only present once, yes.
Yes.
Then you have to do it in the end itself. You cannot do it this way.
Correct. So you first do all the counter like a dictionary, and after you have completely done one pass through the data, then you see what you see, because you can't know, you are doing line by line until you reach the line. You know what is my count of that line. Right?
Yes, exactly. So what we will basically do is for each line I am doing the same thing. So I am storing the count and I am incrementing it plus. So if I do it here itself, then it will, whenever it is true, it will do. So let us first see the question itself, which is error $0 equals to, then we print it. Right. So if I do this and let me do it on this same file itself, and let me copy this line here. So right now I have all the lines are unique except one line which is present 2 times. So if I now run this, so let me make it executable, and if I then run this on this data.txt, you can see only this line which is present 2 times is printed. But if I make it present 3 times or 4 times or 5 times also, then also that line is printed once, right? Because when we are processing this line, the counter is 1. When we are processing this line, the counter becomes 2 and it is printed. Then it becomes 3, 4, 5 later. That time it is not printed again. But when it was 2, it was printed once. So any line that is present 2 times or more.
Just to highlight that, you can also print NR, just to highlight which record number. It's actually the second instance that's getting printed.
Yes. So we can do NR and $0. Yeah. So we can then see that this will be printed in line 6, which is this one. So when the line is present the second time. So whenever the line is processed for the second time, that time itself it is being printed. So later, if it is present more than 2 also, I cannot go back and change what I have done, right? So there is no way of unprinting something. So if I want to print only lines that are present exactly 2 times, so let's say this is line 5th line, I also copy, right? So now this is printing both. This is 5th line and this is a file. Whereas I want only this one because this is present more than 2 times. So what I can do
only in the end block. You cannot do in a process.
Yes,
right?
exactly. So here I can say that for all the key in the ARR, what I will do is if the ARR of key is equal to 2, then print the key. And obviously we don't print the NR because NR will always be the last line number here. So if I do this now, so then you can see only this is 5th line is printed because only that is present 2 times. And the other one, so in the end we have the final count. So I know that hello, this is a file is actually present 5 times. So then this is 5 equals 2, which is not true. So that is not printed. Similarly, you can make it 1 if you want the distinct lines, which is the first option in here, lines that are distinct. So you have to still do it in the end only. You cannot do it outside. And if you make it 2, then this will be the like second option, lines that are represented exactly twice.
Exactly twice. Greater than equal to 2, and then
if you make it greater than equal to 2, then this is the correct option, which is lines that are present 2 or more times. And if you make it greater than 2, then this is the 4th option. And the greater than 2, you can also do outside the end. So how can you do it outside the end if you want lines that are repeated more than twice? Without the end, how can you do it?
ARR of 0 will be 3.
Yes.
ARR of 0 is equal to 3.
So if I make it 3, then this is all lines that are present more than twice. That's the same as this.
During the third instance, basically.
Yeah. Right, so hopefully this is clear why this is the correct option. So let's move on to the next question. So here the question is complete the script to rename all the files in the current directory to include the time of creation in the name itself as given in the example below. So assume all files have creation times. So all file, when we create the file, it will have a creation time stored in its metadata. So in the previous session, we saw we can use the stat command to get all the statistics of a file. And we can use -c to specify exactly which statistic I want. So the format. So %w, as we saw earlier, is the format that prints the like creation time of a file or the birth time of a file. So if I run stat -c %w on any file, the output will be like this. So the time, a human readable time. So 2022, so this is year, this is month, this is date, then there's a space, then the time, hour, minute, second, then dot, then the millisecond, and then space, and then the time zone. So here we want to rename my file, if the name of the file is my file, to be my file underscore the year dash month dash day, then a capital T, and then hour, minute, second. So basically we don't need anything after the dot, along with the dot, and this space should become a T. Right, so we have to first do that. So we have to, so this creation timestamp will give you this string. So first you have to modify that string. So you have to remove the dot from it. So let us try to do it ourselves. So here I have this data.txt file. So if I do stat -c %lowercase w on data.txt, you can see this is the entire thing that is given. So if I store it in a variable, let's say temp, if I do echo temp, then this is the variable. So how do I get, so first of all, how do I remove everything this part? So how do I get only this part?
So I can do grep -o and then replace anything dot followed by that with nothing. Right?
Okay, yeah, we can do that. Yeah.
Also.
Yeah, we can use
set it to remove everything after the period.
Okay, yeah. So a lot of options given, right? So we can use grep. So it was the first option that was told. So anything from the basically starting of the line, anything followed by a dot, right? So anything that is not a dot, let's say. So I can do not a dot present as many times as possible. And if I match that on the temp file, so we get only this part, and I can then use -o to only print that part. So that is one solution using grep. Then you mentioned using cut. So I can do cut by the delimiter, which is the dot, and take the first field on the $temp. So this is the second solution with temp. And then I think someone mentioned sed, right? So I can substitute anything that is the dot followed by any character any number of times till the end of the line with nothing. And that will be the third option. So then also we get this, right? So these are using commands, but then how can I do it directly in bash using variable manipulation? So $temp is this thing. So how can I, without using any command, just using variable manipulation? So because this is simple enough to be done by that. How can I do that?
The space has to be removed, right?
No, so right now we are bothered with removing dot and anything after the dot.
So
Split
the pound sign.
Okay, so temp and then pound
dot
yeah.
And star.
Okay, so multiple things wrong with this. So first of all, like pound means delete from the left. Right?
Sorry, right. So percentage.
Percentage, yes. So if you do
and star should come before the dot.
No. Now this is correct. So if it was pound, then it should be star dot. But if it is percentage, then it is dot star. So this will be correct. So then we get this correct thing. So we can also use double percentage. It will give you the same output because here we only have one dot. If we add multiple dots, it will delete as much as possible with double. So here single percentage is also correct. So this is how we get the date, right? So I can use string manipulation. I can use sed. I can use cut. I can use grep. Right? So in the option, they're using this variable manipulation. So I still went over all of this. So we are familiar with all of them. So now that
here, sir.
Yes, sir.
What is temp here?
So temp is just the variable where I have stored this output of the stat command.
Okay.
So the stat command gives us this total timestamp. So then storing it in a variable, then we can do this variable manipulation.
Okay.
So now if I store it, let's say in another variable, let's say T2 or something like that. So now I have this T2. So how do I now remove this space in between them and replace it with a capital T? Yeah, we can use TR. So I can do TR, substitute space with the capital T with the T2. So this is one correct way. Similarly, we can use sed also, right? So we can do sed, substitute the space with capital T, and this will also do it. But how can I again do it with just simply variable manipulation? How do I substitute in variable manipulation?
So you can do a substring and then append.
No, so yeah, that can be done, but we can directly do substitution, like sed substitution. We can directly do in the variable manipulation.
Slash space slash.
Yes, exactly. The same syntax. So if I do this, then also we basically get the same thing. Right. So this is again like the option that is used in the option. So I went over this, but we can also use obviously sed, tr, etc. So basically, what we have to do is first.
Sed, the three less than signs you're taking. What is that? Like this is standard in, is it? Or it's kind of input to the.
Yeah. So this means whatever string I am giving to the right of it, give it to the standard input of this command.
Correct, but then the string doesn't get stored like that, right? I mean, it doesn't change the string itself.
No, it doesn't change the string itself.
It's not printing any. Okay, it's print. Okay, it's the same thing. Okay.
Yeah. It is just printing to the screen.
Okay.
Yeah.
So the only difference is double less than versus triple less than.
Yeah, double. I don't think is double less than a syntax. Double greater than.
There is a less than, right? Less than also is the.
Yeah, that is taking a file as standard input.
File and giving
and this is taking a string as standard.
Cumulative, right? If it is a stream or whatever, right? I think we have seen that. Keep adding.
No. Okay. Yeah, double less than is for the here doc. So You basically write a document in the code
stuff.
itself, yeah, and it will take it as a file that is given. So yeah, that is a difference. Yeah.
Yeah.
So if you have single less than, this takes as a file, and triple less than means it will take it as a string. So you can basically think single less than as cat, right? So cat some file on some command. This is same as command less than file. And if you do echo some string or some variable, basically anything that you have, if you do that and pipe that to the command, so that is same as the command triple less than the string. And so both are equivalent, but this takes a few nanoseconds more than this.
But there's no concept like in Java, the concept of converting a collection into a stream, right? Not such concept exists in shell.
No, I don't think so. No.
Okay, all right.
I'm not sure. Maybe there may be. I'm not sure if it exists. Right. So what we can do basically, so what we saw is we first store the variable, right? So we store this temp to be the total timestamp, and then we simply remove the dot, right? So the dot star, we remove that. So we get the T2, which is everything till the dot. And then we use the capital T substitution. So we substitute this space with this capital T. So then we have this which we want to add, right? So what we want is we want to move my file to be my file underscore this thing. So then we can simply use the move command. So I can say move the whatever the file is with the file followed by underscore and then followed by the whatever the variable is. So maybe it was stored as T3. So then T3. So this is how this one is done. So let us see the options also. So the first one is simply move file with creation time, substitute space with T. So here we are substituting this space with T, but we have not removed this dot, right? So this millisecond part and the time zone part is not removed, whereas we don't want that in our output. So that is why this is not a correct option. So in the next one, we have simply told move file to creation time. So this is totally wrong. So here we are simply moving the, and this here also we have actually done that mistake. So we are moving the file to be the creation time, but we also need to append the name of the file in the first. So my file should become my file underscore the time, not just the time. And here also we have not removed the dot and the letter, or we have not made the space as T. So this is also incorrect. So the third option is what we basically saw now. So temp equals to creation time. So we can have single person or double person dot star. So we remove everything from the dot. So this entire thing is removed. Then we do the substitution. So we substitute space with T. So we put a T here. And then we move file to be file underscore the time. So this is how we do this question. And then we have the fourth option also, where we are moving the file to be temp. So we don't want to move the file to be just the timestamp. We want file to be moved to the file underscore the timestamp. So the file name should still be there at the first. Timestamp should be appended after that. So that's why only the option 3 is correct. Hopefully this. Sorry. So hopefully this one is clear, right? So let's move on to the next one. Right, so this is again a cron question. So one pattern that you might be noticing is that almost all papers have a cron question. So the last 4 papers had a cron and asked us to tell when it was running. And here we are told when it should be running and ask us the syntax of the cron. So here we have one script that should be run at 10 p.m. every day of the week from Monday to Friday in every month from January through June, and at 9 p.m. every day. So this is the first part. So 10 p.m. every day of the week, Monday to Friday, in every month from January to June. And for the other months, which is July to December, instead of 10 p.m., it should be at 9 p.m. every day of the week from Monday to Friday. So there are 2 schedulings that we have to do. First one is this one, 10 p.m. from Jan to June. Second one is 9 p.m. from July to December. So let us use the crontab guru to see how to do this. So the first we will have like by default we will have star 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 star. So we'll have 5 fields. This is the minute, the hour, the day of the month of the year, and the day of the week. So the first thing is asking us to run it at 10:00 p.m. Right. So what is 10 p.m. in 24-hour format?
22.
22, right? So the hour should be 22. So then the minute is obviously 00. So the minute should be 0. You can also give 00, but just 10 is fine. And then we are asked to run it on every day of the week from Monday to Friday. So not on all the days. So this
1 to 5.
Yeah, so this should be 1 to 5. So this is a Monday through Friday. So 0 is Sunday, which we are not using, and 6 is Saturday, which we are not using. 1 to 5. So 1-5 means all the days from Monday to Friday. And we also have a restriction on the month. So the month should only be January through June. So January is 1 and June is 6. So this one should be 1 to 6. So then we get the correct scheduling. So at 2200 on every day of the week from Monday through Friday in every month from January through June. So this is the first schedule that we need to do.
So January is not 0?
No, so January is 1. So if you see here, it is also given that the day of the month is 1 to 31, month of the year is 1 to 12. So this is one index, this is one index. Hour is obviously like normal, like 24-hour format is 0 index. Minute is also normally 0 index. Only the day of the week is 0 index, because we don't have any normal notation for the day of the week, right? So month we normally write numerically and it is 1 index. So it is kept as that to avoid any confusion. Similarly for the other ones. Day of the week usually just have in the letter, right? So Monday, Tuesday, etc. So to convert it into the numeric notation, it is 0 to 6. Although the 7 also works for backwards compatibility. So if you come here in the day, you can see that 7 in some cron versions is also working. So 7 will also mean Sunday and 0 will also mean Sunday. But 7 meaning Sunday is non-standard. It may or may not work. So ideally it is 0 to 6. But everything else starts from the default ones in their normal meaning. So this is the first thing that we have to do. So we have two schedulings. So this is the first one. And the second one asks us to be at 9 p.m. Every day. So 9 p.m. is simply 21. So at 9 p.m. every day, same Monday to Friday. So this remains 1 to 5. And in every month through July to December. So this simply becomes 7 to 12.
Yeah.
This is the second thing that we need to do. So we have two schedulings. And both of them are on the same file. So the file is home bill autoscript backup. So we have to run home bill autoscript / backup.sh. So this are the two lines we have to have in the cron tab to run this script in these times on these days. So this is not part of the question, but any reason why for the 6 months it is run at 10 and for the 6 months it is run at 9?
Daylight savings.
Daylight saving.
Yes, exactly. So in some countries like US, they have daylight savings, right? So for some of the months, 1 hour gets added or removed. So I'm not clear about that, but then
It's a March, November. Typically, it happens in March. Summer starts in November. It ends. So
yeah,
that's
yeah. So basically, for some months, like there will be plus minus 1 hour. Right? So for some months they want to run it at 9, and for some months they want to run it at 10. Right? So that is obviously not part of the question. So you can see
one more thing.
Yeah.
What if I want to run my job on last day of the February on a leap year? Bouncer.
You do it physically.
No, you can do
It's going to come only once in 4 years.
Yes.
Yeah. You can say 29th of the Feb, right? So let me remove everything.
Leap year, sir.
Yeah, so 29th of Feb is only there on leap years, right?
Okay.
So it will run only on the leap year, basically.
Yeah. So if I want, let's say, particular time, let's say 1500. So at 1500 on day of the month 29 in February. So obviously this is not possible in any other year. Only in leap year we will get 29th of February. So it will still work correctly.
If I modify the question, 28 February of a leap year, then I can't.
Then you should write a script. Yeah. Okay. And for taking off leap year also, you cannot simply check if it's divisible by 4, right? That also has a more complicated condition.
Correct.
So yeah, so this is basically the solution for it. So in the second option, they've given like 10 and 9, right? So as we saw, hour is 0 to 23. So this is 24-hour format. Because it was PM, so it has to be 22 and 21, not 10 and 9. And similarly, we have So we have basically swapped the last and the second last field in the third option. So that is obviously not correct. And in the fourth one, what is wrong in the fourth one? I think okay, so the timing is different. So instead of 22-21, it is 21-22. Right, so this is also not correct. So the first option is the correct option in this. So hopefully this is clear. Let's move on to the next one. So in this question, a student named Varsha has a lot of configuration files in her Linux system. Somehow she lost all the data, but fortunately she backed up her configuration files in a specific way such that the backup directory named backup_config contains all the configuration files along with one file named files. So I think this question was also there in some quiz 1 or quiz 2. I remember seeing this question. So the files contains the absolute path to the config files, one path per line for each config file. Choose the script that restores all the files to their location. Assume that the backup directory contains only files and not directories. Now, the current working directory where the script are run is the backup config. Right, so what we are told is we have some files in a folder, and we also have another file called files, which contains the absolute paths to these files. So in our folder, we will have some files. So let me actually create a folder. So in here, I don't have anything right now. So let's say I have a file called A, which has the letter A. I have a file called B, which has the letter B. And I have a file called C, which has the letter C. And I'll also have a file named files, which will give me the path. Right. So right now my current working directory is this one. So let's say the folder that I want is same, but instead of 134, it is 135. Right. So what I will have is I'll just paste this and let me increase this to 135 and copy paste this. Right. So now we have the paths given as this folder /A/B/C. So this is the absolute paths of the files. So as you can see in the files, absolute path to the config files, which was there but now got deleted. So what we now have to do in this script is first we read each line by line, and then we extract the name of the file. Right. So the name obviously will be the same. So here also it is ABC, and in the files also it is ABC. We extract the name one by one. So now we know which file I want to copy, and then we simply copy that file into this path. So let me also actually make this folder so it exists. I can just go there. And so now you can see I am in that folder. So let me now go back to 134. So now you can see I have this A, B, C, and this files. So let me now create another file called script.sh where I will be writing the bash script. So here what we need to do is we have this all these files, but we have this files file which we need to read. So we will simply read each line of that file one by one. So we will simply go over that file. So we can read lines using this while loop. And then for each of that line, we simply take the last part. So if you see the files, we have a path. So how do I get only the name of the file from a path?
Percentage less.
Yes. So I can not percentage because I want to drop from the left. Right. So I will be using the pound symbol. So I can either get like the file name this way by using the line and then drop from the left as much as possible, anything followed by a star. So this is one way of getting it. And we can also use the base name command. So I can also say base name of the file. I don't need this one. Sorry, not file name, base name of the line. So both of these are valid ways. So I can either use the base name command, which is made for only doing this exact thing, or I can also use the bash string manipulation to remove everything in that line from the start till the last /. So now I have the file name. Then we will simply copy this file from here into that path. Right. So how do I do that? We will use the CP. Yeah, CP file name, and then dollar line. Yeah, right. So we copy the file in the current directory. So we are using relative path here, just the name of the file, into the this location. So if I do ll on this 135 where it should be stored, so right now it is empty. So if I now run this, assuming I did not make any mistake in the script, so now if I do ll, so you can see all the files A, B, C have been moved there. And in this folder, I also had script.sh, but that was not moved because it is not part of the files file. So only the files listed in the files file that got copied from this backup folder into the folder, which was like whose path was given. Right. So this is how we can do this. So let us see what is the options. So the first option is for file in cat files, do cp file and substitute star with nothing. So this is obviously not correct because we are substituting anything with nothing. So this will remove everything. And we are removing colon, so which is also not part of the line at all. So this option does not make any sense. So this is what we had done, right? So while read a file, do done file. So we're reading each line of the file and that is stored as the file. And what we have done is we have used the pound to remove everything from the start, which is the star slash. So anything till the last slash we are removing. So that gives us just the name of the file or the base name. So we are copying that base name, which is the current directories file, into the full path. So this is the second option, which is the correct. And we also have other correct options. So we can also, instead of doing this, what we can do is we can substitute star and then followed by forward slash with nothing. Right. So what does the double forward slash mean here? In bash,
all the occurrences. All the
yes,
occurrences.
right. So this is same as the G in sed. So we do it for all the occurrences in the line. So here what we are saying is in the file, which is basically this each line, we are substituting all the occurrences of anything followed by a forward slash. So anything followed by a forward slash is basically this thing, then, sorry, let me print it again. So this thing, then this thing, then this thing. So everything is removed. So everything is substituted by nothing. So this entire thing gets removed and we only are left with the A. So this is also another way of getting the base name. So instead of removing this way, we can also remove this way. And then we are doing the same thing again. So this is also another option which is correct. And in the fourth option, what we have done is for file in cat files, do cp file into this. So here the order is incorrect, right? So we are trying to copy the absolute path file in the current place. So obviously this does not exist. That's why we are running the script to recreate that. So that's why this is also not correct.
So can you show the option 3?
Yeah.
In option 3, we say anything followed by slash should be.
Yeah. So any character, any number of times followed by a forward slash that I am substituting with nothing. So I am removing that basically.
But in that case, the first slash will remain, right?
No, because star also matches nothing. So nothing also will be matching the star.
No, so, my question is the first slash before the home. That will remain. It will only
because we are matching. So what is the pattern that we are matching? Star followed by forward slash, right? So here nothing which is there, that will also match star. So star forward slash will match something followed by a forward slash or nothing followed by forward slash also. So this will be removed and then this will be removed, then this will be removed, then this and then this will be removed.
So why will it not remove slash A? The last
because we are matching anything followed by a forward slash. So A is not followed by
it does not have a forward slash. But even in this case, it's start of the line. So even in that case, it will take nothing. It will consider nothing.
Yeah. So let me actually do this. So let me read it into a line, right? So let me do it on files. So you can see now it contains the first line, right? So if I now do so what we did earlier, which is simpler. So we can say anything followed by slash. So I'll just get A. But instead of this, if I do the replacement, right? So replace all the occurrences of star followed by forward slash with nothing. So then also I get A because even this first forward slash So I have star and then followed by a forward slash. So nothing which is present before this forward slash also matches with star. So star means any character present 0 or more times. So we are matching 0 times here.
Yeah, no, I was confused with start of the line, and I thought there should be like, a space or something. I mean,
no. So even if nothing is
there, okay.
Yeah, it will match. Yeah. Okay, so that's why these two options are the correct options. So let's move on to the next one. So here we have choose the matching line for any of the following regular expressions. Assume that regular expression is using ERE. So what does this question mean? Choose the matching line or lines for any of the following. Okay, so choose a option which will match any of these regexes. So it does not have to match all of them. It has to match any of them. So each option we have to see whether it is matching these. So what are the regexes? The first regex is start of line, end of line. So what does this mean?
Empty line.
Empty line.
Empty line, right? So any empty line will match this. Then we have start of line, then a group which is 1 digit, and then that group is repeated 3 or more times, and then the end of line. So what does this line?
Comma, yes, right. 3.
Sorry?
What is that comma? 3.
No, the comma means 3 or more times. So if you just had 3, that means exactly 3 times.
Okay, got it.
The comma means 3 or more times.
So it starts with 3 digits and also ends.
Yeah. So what does that mean? So a line which
the entire all digits.
Only consisting of numbers only, at least 3 or more numbers.
Yes. A line consisting of 3 or more numbers and only numbers.
Right.
Yeah. And the last one is starts with any character that is not a dot present 1 or more times. Right. So the line should not contain any dot, and the line should contain at least one character which is not a dot. Right. So that's what these 3 regexes mean. So let us see the option. So an empty line. So as we saw, the first option will match an empty line. So that's why an empty line is correct. Then we have a line having a number with only 1 decimal point, that is 10.1. So we saw first option will not match because it is not empty. Second option will not match because it has to be only numbers and present 3 or more times. So this has a digit also. So this will not match. And the third one needs to have no dots in it, right? So third one will also not match. So that's why option B will not be correct. So in the third one, we have a line without a space. So if we have any line without a space, that need not necessarily match this because that line might have a dot also. Right? So if it is a line which has characters including a dot, then none of these regexes will match. So it is not empty, it is not only digit, and it is also not non-dot. So that's why a line without a space will not necessarily always match this. Only if it does not have any dot will it match this. And similarly, a line with 3 spaces also does not match the first one or the second one. But the third one may or may not match depending on whether it has a dot in it or not. So it will not always match. So if it is a line which has only 3 spaces, then it will match. But if it is just a line with 3 spaces, then we cannot be sure whether it will always match or not. So if it has a dot, then it will not match.
So what is the third one again? Basically, it should not have a dot.
Yeah, so it should be a line that has at least 1 character, and the line should not have any dots.
Correct.
And the fifth option is the line starts with 2 consecutive numbers. So if it just starts with 2 consecutive numbers, that obviously first one will not match, and second one will need 3 or more, and it has to be the entire thing of the line, not just starting. And the last one again we cannot specify unless we know there is no dot in it. Right? So this option will also not match any of these. So the next option is a line containing only 4 consecutive numbers. So the line only contains numbers and 4 consecutive numbers. So then it will match the second regex, which says it has to be 3 or more consecutive digits, and that is the entire thing of the line. So this one matches. And then we have a line without a dot. So that is matching the third option, right? So any line, whether it has numbers, whether it has letters, whether it has spaces or not, 1 space, 3 space, doesn't matter. If it is a line without any dot, then the third option will match.
So the previous option, it says only 4 consecutive numbers, but here it could be 3 or more, right?
Yeah, so A line consisting of 4 consecutive numbers will also match this regex, right?
Okay, we have to we have to interpret.
So we are saying which options will match this regex. Okay. So that will also match this regex. And then last option is a line with 1 or more dot characters. So obviously that will not match because none of them will match. So it is not empty. It obviously contains dot, and it is also not entirely digits. So last one is not correct. So let me know if this is clear, if any option is confusing.
Okay, this is close. MSQ with 8 options. We still have 2 more to go, right?
Yeah.
Sir, one question here. Can you go little up?
Yeah.
After the curly braces 3, comma is there, sir. What does it indicate? Comma indicates.
So it means it can be present 3 or more times. Minimum 3, but maximum infinity.
Okay, sir. Thank you.
Yeah. Okay. So let's move on to the next question. So here,
comma is before.
Then it means maximum 3 and minimum 0.
Okay.
So let's try that out actually.
Maximum 3 times. Yeah.
Yeah. So if I have let me just create a file here itself. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Right, and also ABC. So if I am spelling to match the start of the line and then 0 to 9, present, so this has to be ERE, present 3 or more times on the data. So it will match 1, 2, 3 and 1, 2, 3, 4. And if I say present 3 or less times, so it will match 1, 2, 3. Oh, sorry, I forgot to give the dollar here. So it will match 1, 2, 3. It will match 1, 2. It will match 1. But it will not match ABC. Okay, so this does not mean 0. So minimum is 1. So at least 1 has to be there. If I put, what happens if I put 0 here explicitly? Okay, still it is, oh, because I don't have any empty line.
So you have to have an empty line actually.
Yeah, I have to have an empty line. Yeah, sorry. So yeah, comma means 0 also. So 0 is the minimum and 3 is the maximum. So you can see this empty line is also matching, and these 1, 2, 3 are also matching. So if I put explicitly 0 also, that is also the same thing. The empty line will also match. And if you don't want empty line, then you have to give 1, 3. So then only non-empty lines with 1, 2, or 3 digits will match. Hopefully this is clear. Right, so let's move on. So next we have a bash script. So we're told consider a file named data containing some text located in the current working directory. Select the correct statements for the output printed by the below script. So we have count equals 0, while read line do, and then we have some help in the comments. So we are told -o in grep will print only the match, not the entire line, and prints 1 match per line. So then I'm doing for I in echo. So this is inside backticks. So I'm not sure if this is very clearly visible, but this is backticks, same as dollar and then round brackets. So I'm executing this command, and on its output, I'm running a for loop. So for I in echo line, grep -o in quotation tilde iter tilde. Right, so I'm searching for this word tilde iter tilde, and I'm only printing that. So grep -o will only print the matches and each match on a separate line. And I'm basically then iterating over them. So iterating over all the lines. And I'm simply incrementing the count, right? So count equals count plus plus. So count plus plus means count equals count plus 1. And then the line which we have in that loop. So what I'm doing is line equals line, and then I am substituting that iter with the count. So the first iter I'm substituting with the current count. So iter is replaced with count. So every time, so as many iter as there are in that line, that will be substituted by their count. So the first iter will become 1, second iter will become 2, etc. And in the end, I am simply printing each line. So after doing this substitution on the line, I am printing that line, and I'm running it on the data. Right, so let us run this and see what is the output. So I can have a file. Sorry, I'm in the same place. So I can have a file which is data, and let us have some text here. and we need to have some iters in it. So let's say I have a iter here. So let me maybe add another iter here. So the iterator, like the count will never reset, right? It's only resetting as 0 in the first, and then for each line it is not resetting. So this will basically become 1, 2, and this will not become 1 again. This will become 3 and then 4. So let's see that. So let us create a script. So script.sh, and here let us do while read line do, and here we will be doing we need the count also. Count equals 0, and for I in this, which is echo line, and then grep minus o tilde iter tilde, and on that what we're doing is we're doing count. So we just do this one, count plus plus to increase the count, and then what we're doing is line equals the line where the first occurrence of the iter will be substituted by the count. Right. So hopefully this is the same as what is given in the question. Do let me know if we have made any mistakes. So then we simply print that line, and then we are done, and we get it over the data.txt. Right. So just let me know if everything is the same, or yeah, everything looks
the dollar line is in quotation, double quote, echo.
Yeah, that is a best practice.
And even on the line 4, whatever, just before that. Yes.
Right, so this is correct. Yeah. So now let's see what will be the output. So if I do bash script.sh, you can see this is hello, how are you? This is demo file, and then iter becomes 1, how are you? Then iter becomes 2, and then the next iter becomes 3, and then it becomes 4. So this is what this script is doing. So for all the occurrences of tilde iter tilde, they simply replacing that with the occurrence number of that in the file. So like what is the number of the occurrence of that iter in that file. Now let us see the options. Only the first occurrence of iter in every line of the file data is replaced. Right. So we may think this because in this we have used a single forward slash. Right. And what the single forward slash does is it will only replace the first occurrence of it. But what happens is after replacing the first occurrence, we are storing that as the line itself. So first the line is this thing, and then we are replacing the first iter with 1. So now the line itself becomes 1, how are you iter you. Sorry, 1, how are iter you. So then in the next iteration, again the first iter itself is the next one. So even though in each iteration we are only replacing the first iter in that line, eventually we will be replacing all the iters in that line. So we are not replacing only the first occurrence. Eventually, after everything is done, we have replaced all the occurrences of iter in the entire file. So the next option is the value replaced with iter is constant across the line. That is also not true because we are doing count plus plus. The third option is the value of count at the end of execution and the total number of occurrences of iter in the file are equal. So this is true because as many iters as there are, we are incrementing count that many times. So after the entire loop is done, the value of count will be same as the number of iters that are there in the file. And the fourth option is the same result can be achieved within the file with the following script. So here what we are doing is c equals 0 while grep q iter. So what we are doing here is we are running grep on the we're not running it on any file. Okay, so we are searching for the iter, and then we are doing c++. So we are incrementing the count, and we are substituting the iter with the $C. So this, I think you have to pass as the standard input for this to work. So let us try the script as well. So let this be sc2.sh. So here what we are doing is c equals 0 while $grep q tilde iter tilde. So as long as there is like iter in the file, do, and then we are incrementing C. So we are going to do C++, and then we will be substituting that. So we are only substituting the first occurrence because we are doing it in a loop. So every time the first occurrence changes. So we are substituting the iter with the count, which is $C. Okay, and then we are done. So if we simply run this, then it will obviously not do anything. Right? If I simply do -sc2, then it will simply wait for our input. But if I cat the data.txt2 -sc2, then also it is not doing anything. Right? It's not printing. So I think there is some issue in this script. That's why this is not working correctly, because we are anyway running this in a sub shell, so it will not get the standard input from what we are providing. So
less than in the script itself.
If you do it here, so data.txt,
yeah,
this will still not work because I'm giving this to the while, but I'm running the grep inside a subshell. So I think the way this was supposed to be done is by giving the file here, data.txt, and doing the substitution here maybe as data.txt. So this will actually like change the file itself, but then this will work. So if so right now, if we see the data.txt, it has the iters. And if I run this -sc2.sh, and then if I do data.txt, so now it has substituted, but the count has been replaced, right? So it has like reset. So it's 1, 2, and then again 1, 2. So why is that?
Is not correct then, because it's running in a subset. Okay? What if it is source, so it runs within the original cell?
No, even if you, so let me reset that first. So let me save this. So again, the file is back. So even if you source this sc2, then also it will, so this is still running in a subshell only.
Yeah.
So this will still do this, and I'm not sure why the counter is again resetting in the next line.
Control is it creating a new subshell every time there's a loop?
Yeah, in each iteration, this is running every time, and then it is seeing its exit status.
Correct. So the only way to do that is if you bring the PID and PPID, then you will know clearly that it's actually happening. Inside the process block, inside the loop block.
So I guess this. Okay, so I'm not sure why this is resetting back to 1 and 2. So anyway, so this script is obviously not equivalent. So this option should obviously not be correct, because even this version is not correct, and even if we like change it also, then also it is not correct. So okay, yeah, I get what is the issue, because set does it line by line, right? So it is substituting all the first occurrences of iter with 1 itself. So in the first time itself, it is making this also 1 and this also 1. So using set this way will not work. So yeah, so this given script is not the same as what this script is doing. So this option should not be correct. So this third option is the only correct option in this. Do we have any other option? No. So yeah, out of these 4, only the third option should be correct.
So some poor students have been penalized in the past.
Yeah. Let's just let me know if this is clear, how this script is working and why the third option is correct. Right, so let's move on to the next one. So I'll check what is supposed to be for this. Most probably this is a wrong, so I'll just let you know.
Maybe the key was corrected later on, right? Because they published the PDF and then there was a error.
Yeah. Right, so let's move on to the next question. So in this, the question is how many lines will be printed after executing the below script. So here we have a for loop for I in 1 to .10. So this will run 10 times from 1 to 10, and we have f equals 0. Then if I mod 3 equals 0, which means if I is a multiple of 3, then f equals 1, continue. If f equals to 1, and I greater than 5, then continue. Finally, echo star star star. So only if this continue is not done and if this continue is not done, only then the control will come till here and we will see the star star star. So let us see what are the possible numbers from 1 to 10 and try this out. So if I paste this here and let us just dry run this. So from 1 to 10, we have the 10 numbers. So let me just write it down: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So in the first iteration, so the value of, so this is the value of I, and then we'll have the value of F. So at the start, the value of F is, so for each iteration at the start, the value of F is 0. So value of F is always set to be 0 at the start of the iteration. So F is 0 at first. And we are seeing if I mod 3 is equal to 0, so which is not true. So then this is not done. And if F is equal to 1, which is also not true because F is 0. So then we print the star star star. So we print one line for the I equals 1. Then for I equals 2, again F is 0. So and 2 mod 3 is also not true. So this is not done. And obviously this is also not done. So again here also we print the line. So for I equals 3, so in this case, now F is 0, but now because I mod 3 equals 0, that's why we have F equals 1 and continue. So F becomes 1 and then we continue the loop. So we again start in the next iteration. So actually this condition is actually never satisfied, because for this to be satisfied, this condition has to be unsatisfied. So if this is satisfied, we are continuing. So anyway, we are not checking this. We are going into the next iteration. And if this is not satisfied, then the value of F is always 0, because only inside here we are setting it to 1. So then this is never satisfied. So actually, we never even have to check this condition. This is never going to be true. So we just check this condition. So for all the multiples of 3, we ignore, so we don't print it. And for all the non-multiples of 3, we print it. So out of 1 to 10, 3 is a multiple of 3, 6 is a multiple of 3, and 9 is a multiple of 3. So 10 minus 3, we get 7 numbers for which we are printing star star star. So the output will basically be 7 star star stars. So the question which asks how many lines will be printed after this, so the answer is 7. Okay, so just let me know if this is clear. So why we are ignoring this if condition? Because
break. In case of continue, you do a break.
So if you're doing break, then the answer will be 2, because the first time we are getting I equals 3, that time itself the entire loop will stop. So we have just printed start 2 times and then we don't do anything at all.
So nothing will be printed, 0.
Yeah. No, it will be printed 2 times for the I equals 1 and I equals 2. For the I equals 3, yeah, so then we will break. So the answer is 2 for that. Because we have continued here. So few things. So F is reset every time in this loop, and F is set to 1 only inside this. But after, as soon as it is set to 1, we are doing continue. So again, F is becoming 0. So F never stays 1 when it is going to check this condition. So this condition is always false. That's why we can totally disregard this entire condition. So we only check this.
Other question is, if we remove the continue word from the first loop, that will be another question.
Yeah, then it will be interesting, because you have to see if it is multiple of 3, then F is 1, and then basically you see if it is greater than 5. So only if I is greater than 5 and a multiple of 3. So basically only for 6 and 9, not for 3. So then the answer will be 8.
8.
Yeah.
So continue will basically, whenever this condition is false, we'll say continue so that the loop can go ahead.
Yeah, so continue, whenever we encounter continue, it will not do anything else which is there in the loop below it. It will directly go into the next iteration.
Okay, so whenever this is true, it will, okay.
Yeah. So hopefully this is clear how we are getting 7. So let's move on to the next one. So this question is: the input file to the below said script named data contains 100 characters. Among them, 47 are numbers, which is 0 to 9. How many characters will be in the output after executing the below script? Assume that said is using ERE. Right. So in this, what we are doing is, first line is substitute a digit. So we are grouping it. So substitute any like one digit in a group with that digit followed by itself again. Right. So if I have, let's say 7, it will make it 7 7. So it will duplicate each digit, and we are doing it G. So we are doing it for all the occurrences. Then afterwards, what we are doing is another substitution. So again, we are matching any digit and we are grouping it, followed by that digit again, right? So in the search, so with this forward slash and this forward slash. So anything between that is the search. So I'm searching for any digit present 2 times and substituting that with that digit present only once. And that also I'm doing for all occurrences in the line. Right. So
back to square one.
yeah. So basically what we did. Yeah. So we did and then we undid what we did. So in this case, then basically we had 47 numbers to begin with, so the answer should still be 47, right? Okay, so why is it 100?
No, overall how many? 47 plus 53, right?
How many characters will be in the output?
Yeah, there will be 100. Right?
Okay, yeah. How many characters will be there in the output? Yeah, so total 100 characters were there. 47 numbers will remain 47 numbers. The however is 100 minus 47, that many will remain as it is. So total will remain as 100. Yeah. So we can also run this and confirm. So we can see how it is working. So we can do it step by step. So let us first have a file which has 100 characters, right? So how do I have 100 characters in it? Let me have 47, right? So 47 numbers. So let me have 47 numbers in data, and then let me have the remaining. So what is the remaining?
So will that work for 1 to 47? Because the two number that will be.
Oh, okay, yeah. My bad. So there are double digits also, right? So
yeah, you have to take 1 to 9 and do it multiple times.
Let me
or
do
0 to 9 and multiple.
Let me do something. Let me cat/dev random, and from here let me remove anything that is not 0 to 9.
It will work with 1 to 47 also, because it will take those digits which are like double, like 11, 22, 33, right? Or not?
Yeah, but before that we are already doubling. So if we're removing like deleting or doubling, then if we had doubled once, then the doubling will be removed. But if we have like already a number present 2 times, then it will still remain as it is. So that will not be an issue. So yeah, let me take this. And how do I take only a few characters? I've actually forgotten. 1 second.
Finally, something Shine doesn't know.
No, I know because I have added it in, but I have forgotten. So yeah, this is not in this. It's there here, so I know how to do it. Yeah, we can use the -c in head. Right. So in head we have the -c to take not this many lines, but this many characters or bytes. So I can do head -c 47 to get exactly 47 characters. Right. So what I'm doing is I'm taking random numbers, letters, ASCII, Unicode, etc. from dev random. So these are just bytes, and I'm deleting anything that is not a number. So then I'm left with only stream of numbers, and I'm only taking the first 47 of them. Right. So I have basically this.
TR minus CD is what, Shine?
So minus D means delete, right? So drop, and minus C means complement of whatever I'm telling. So complement of 0 to 9 means any character that is not 0 to 9. So then drop those characters. I'm left with only 0 to 9. So then if I store this in data, and similarly I can do basically A to Z, right? So I can get letters also, and 53, right? Okay. Yeah. So then I get random letters. So this also I can store it in data. So then my data is basically this 47 numbers and then 53 letters. So then if on this we do this following script. So let me create a script.sed. So bin sed f. So if we just do the first thing, which is 0 to 9, and followed by, so I'm replacing that with the same thing 2 times for every, all the occurrences. So if I just do this, if I do sed minus ef trip.sed on the data, so then we basically get all the numbers doubled, right? So 0, so I think we had 2 zeros. So, sorry. So the data, we had 2 zeros at the start. So it basically makes it 4 zeros. And then we had 3, it becomes 3, 3. And then we had 1, it becomes 1, 1. So every digit becomes double, but the letters remain the same. So this will give you how many characters? This will give you 147 characters. So the 47 will become 47 times 2. So this will become 47 into 2 plus 53. So this will give you 147 characters. But if we then again undo what we have done, right? So we again do a substitution, and this time we find any digit which is present 2 times side by side, and we substitute that with just that digit present only once. So basically whatever doubling we did, we again undo that. So then again we get that, right? So you can see, even though we had 0, 0 and it became 0, 0, 0, 0, then again it became back into 0, 0. So this will not squeeze naturally consecutive same digits to be just 1. So that will still remain as it is. And the number of characters will still remain 100 as it was. Okay, so hopefully this is clear why the output here is 100. Right, so let's move on. So in the next question, we have what will be the output from the below script. So we have an awk script where we have for each line we have taken 2 arrays, so associative arrays x and y. So we are doing x nr. So nr is the line number of that current line. So x nr equals $1. So I'm storing the first column for each line in our associative array or a dictionary, and y nr equals $2. So in y I'm storing column 2. Then I'm also having x underscore and y underscore, and I'm doing x underscore plus equals $1, y underscore plus equals $2. So here I'm storing the sum of the values. So x is all the values and y is all the values of column 2, and x underscore is sum of all the column 1 values, y underscore is sum of all the column 2 values. Then in the end, we are doing x underscore equals x underscore by nr. So what does this mean? Sum of all the values divided by the number of values.
Average.
Average. Yeah. So x underscore will then store the average of column 1, and y underscore will store the average of column 2. So this is not exactly average. So if there is any non-numeric value, so it will add that as 0, but the nr will still count that as a line. So that will not work. But if all the column 1 and column 2 are numbers, then it will be average. And then x, I am assuming this is denominator. So then x underscore 2 is 0. Then y underscore 2 is 0. So this is 2 variables we initialize into 0. Then for I in x, so for all the variables in column 1, we are doing num plus equals xi minus x underscore, right? So this is the ith value of column 1 minus the average value of column 1 into the ith value of column 2 minus the average value of column 2, right? And then this is, we are storing as the numerator. So num plus equals this, and then x2 plus equals the x value minus the average x value whole square, and the y value minus y average value whole square. So this is basically, I'm guessing, taking the like
covariance by standard deviation.
Covariance, yeah.
Correlation between column 1 and column 2.
So x and y are the like column 1 and column 2, and then we are printing the numerator by the denominator square root and into the denominator 2 square root, right? So, and then we are passing into it these values. So 1, 2, 3, 4, 5, 6, 7, 8. So basically we have to do a dry run, and like in the hall, obviously we won't be able to execute this. So you have to, on pen and paper, you have to basically do this. So you have to first store the average. So 1, 3, 5, 7, you can get the average. 2, 4, 6, 8, you can get the average. Then for each values, you have to
bar whole square.
Yeah, so you have to then like basically do this equation, right? So you have to do xi minus x bar, yi minus y bar, multiply it. In the denominator, you have to do
Here,
x.
y can be expressed as a function of y equal to x plus 1. Basically, all the points will lie on a line, so
Yeah.
it should be 1.
Yeah, okay. So let us see the answer. Yes, the answer is 1. Right. So yeah, if you're familiar with what this is doing, then you actually don't even have to perform the calculation, right? So as you said, as we saw everything, it is a linear combination of this, right? So they are linearly dependent. So in that case, the answer will be 1. So even without performing the calculation, we can get that the answer will be 1. But even if we don't know this, we can also still like do it manually to get the answer. So even then we should be able to get the answer. It's hopefully this
starts 1 in cell scripting. It's kind of
yeah,
that's good.
But thankfully, even if you don't remember that, you can still get the answer because only 4 data points are there. It will not take a lot of time. And so hopefully this is clear. So this is basically like like following a pseudocode. So there's not much to explain in this. So let's move on. Okay, so this is the last question of this paper. Right, so that's all for the 2022 September forenoon paper. So next we will be doing the all the other papers also in the upcoming.
Shan, you're going to put it up like last time, like every
Yeah,
time.
I'll upload the recording.
Thanks.
Yeah. So let me know if there is any confusion regarding this paper. Otherwise, I'll stop the recording and then we can discuss other things. So let me stop the recording.